Hi kids, here comes Objective 9. Notes are really the highlights of our notes. This was a lesson that took a couple days, so this brief video is meant to be a recap of the crucial things that you'll need to get by. Of course, if you have any other questions, you're very welcome to come find me and I can help you. So in this objective, we will get to the point where we will evaluate or solve square roots, specifically for small perfect squares and small perfect cubes. Before we do that, though, we need an introduction on square roots and cube roots. And as we go, we'll keep square roots on the left and cube roots on the right, and you will see that as we go through level by level, each of these subjects are closely related, but just a little bit off, just a dimension off is kind of the joke. So when we're talking about square roots, if we're literally looking at a square, that would be the side length or the edge of a square, and that would be related to, say, area. When we're looking for the surface area of a square, that would be the side length times itself, because all sides of a square are the same. Length times width would just be the same side length times itself, or the side length squared. So let's say hypothetically that this square has a area of 16 units squared, and we need to find the side length. What we're doing is finding what number times itself gives us 16. 4 times 4 is 16, so the side length is 4. Another way that you can look at this, which kind of destroys the picture that I have here, is if I make 16 squares, small ones, the side length is 1, 2, 3, 4 units for each length. So we can say that the square root of 16 is 4, or we can say the opposite of that is 4 squared is 16. This means 4 times 4, not 4 times 2. Now this little number here, it's not called the flying number, it's not called the tiny number. This is called the exponent. And for this lesson, we will be using squares and cubes. An exponent of 2 is what we call square, so we would call this 4 squared. 3's are cubes, which we'll talk about in just a moment. So for cube roots, let's start by looking at a literal cube. Similar to a square root, this is still the side length of a cube. Now this is a three-dimensional object, and when we are looking at this, trying to consider how many smaller cubes would fit into this, that's an issue of volume. And to find the volume of an cube, perfect cube with all the same sides, it would be length times width times height, or the same value multiplied with itself 3 times. So in this case, again, the side length is 4. If we have, I'm sorry, I didn't give you that crucial information, 64 units cubed, I'm sorry. So if I had a cube with 64 units cubed volume, or that means within this larger cube, there's 64 smaller cubes, a side length would need to be 4, because the cube root of 64 is 4. If you wanted to do an illustration of that one, while wrecking our notes that we wrote in here, here's your 4x4 that you had with a square, but now it's extending to this other dimension here. So the side length is 4, the cube root is 4, or we could say the reverse, 4 cubed is 64, which is 4 times 4 times 4, not 4 times 3. And so we would read this 4 cubed. Other exponents larger than that, say 4 and then a small 4 raised above as the exponent, that would be called 4 to the 4th, a 4 to the 5th, a 4 to the 6th as the number of the exponent increases. Okay, so in sum, we can boil it all down to this. A square root is one of two equal factors. Now this can be misconstrued by students. Sometimes they focus on the equal part and sometimes they focus on the two part, but a square root must be both two factors, and those factors also must be equal. So let's do a couple examples of what a square root is not. So let's go back to factor trees from way back when, and we are factoring the number 16 as far as it will go. And I'm left with the factor of 2. These are equal factors. But 2 is not the square root of 16. 4 is the square root of 16. These are equal factors, but there's 4 of them. So 2 is not the square root of 16. Or students will break it down this way. 2 times 8 is 16. Here are two factors, so the square root of 16 are 2 and 8. But that can't be. It has to be one or the other. These are not equal factors. So a square root is one of the two equal factors. Here are two factors and they are equal. So this is a no example, this is a no example, and this is a yes example. Okay, so similarly, on the other side, a cube root is one of three factors of a number. And let's talk about what it's not. So if you factor this 64 from our previous example all the way down, here we have equal factors. But the cube root of 64 is not 2. These are equal factors, but there's 6 of them. There need to be just 3 of them. This is a no example. Or you can say 64 can be broken down in a 2, 4, and 8. These are 3 factors, but they're not equal. A number can only have one cube root. There's 3 here. So this is another no example. A factor tree for a cube root looks a little bit different. It has a third branch. 4 times 4 times 4. Here's 3 factors and they are equal. So this is a yes example. So there's an overview of square roots and cube roots. In general, let's look at how they relate to perfect squares and perfect cubes. So any number has a square root or a cube root, but only some numbers are perfect squares and perfect cubes. So a perfect square is a rational number whose square root, because we're talking about squares here, is a whole number or an integer. Now, if you've been using our calculators, the button for a square root is here, above the 7. So square root of 1 is 1. 1 is a whole number. So we can say that the square root of 1, because it equals 1, 1 is a perfect square. Square root of 2 is this long decimal, so it's not a whole number. So 2 is not a perfect square because its square root is this long decimal that is irrational, doesn't end, doesn't repeat. Square root of 3, same thing. Long decimal, doesn't end, doesn't repeat. It's an irrational number, and so forth. Square root of 4 is 2. So that makes 4 a perfect square because its square root is 2. Square root of 5, square root of 6, square root of 7. These are all not perfect squares until we make it to the square root of 9. The square root of 9 is another perfect square because its square root is a 3. That means the square root of 5, 6, 7, 8 are not perfect squares. Now if you look here, we have 1, 2, 3, 4. The square root of what is 4? 16, because 4 squared is 16. 1, 2, 3, 4, 5. The square root of 25 is 5, and so 25 is a perfect square. So from this, we can make a list of all of our perfect squares. 1, 4, 9, 16, 25. Six squared is 36. 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 13 squared, 14 squared, and so on. That's typically the ones that we use for our class. So all of the numbers that aren't these are not perfect squares because their square roots are not an integer. They're not a whole number. Okay, let's look then at the other side. 2 perfect cubes. These are numbers whose cube root are whole numbers again, or integers. All right, to find the cube root of a number using these calculators, you'll need to know this sequence here. You'll push 3, second, the caret button, the number you're finding the cube root of, and enter. So if you want to find the cube root of 1, you'll push 3, second, caret, we're finding the cube root of 1, then enter. So the cube root of 1 is 1. That means that 1 is a perfect cube. Now let's test some other ones. Let's try 2. So 3, second, caret, 2. Nope. Because it's not a whole number. It's not an integer. 3, second, caret, 3. Nope, not the cube root of 3. Let's find the cube root of 4. Nope. Let's keep going until we find one. 5, 6, 7, 8. Oh, we found one. The cube root of 8 is 2. So that means the cube root of 5, the cube root of 6, the cube root of 7, none of these worked. Well, it looks like we have the beginnings of a new pattern. 1, 2, 3. Well, the cube root of what number is 3? We can do 3 times 3 times 3, or we can do 3 caret 3, which is 27. So that means that the cube root of 27 must be 3. Let's try that out. 3 second caret 27 equals, yeah, that worked. Let's try our 4. 4 cubed is 64. So that means 64 is a perfect cube. Typically in our class, we don't use as many of these perfect cubes. We keep it at 1, 8, 27, 64, 125, that's 5 cubes. Sometimes we use 6 cubed, which is 216, and so forth. Okay. All right, so there is an overview of perfect cubes and perfect squares. And this is kind of getting at our objective, which is to evaluate square roots of small perfect squares and cube roots of small perfect cubes. This is kind of a calculator lesson, really. Can you calculate or can you evaluate or solve these things? So I'm on the redo side. Your homework will be the regular side, but I wanted to use this for our examples. So truly, there are about 4 different types of questions here. So the first is a square root. So for a square root, you're just using this button here. Ooh, I pushed it twice. The one that's over the 7. So the square root of 196 is 14. You should try that on your own and make sure you get the right thing. And then there are cube roots. So down here is 216. Cube root is 216. That's where you go. 3 second caret 216, just like what we did in our notes to get 6. So that's square roots and cube roots, using this button for square root or the 3 second caret for the cube roots. Then there are finding our squares and our cubes. For 6 squared, you can either do 6 times 6, or you can do 6 caret 2 for 6 to the 2nd power, or 6 squared, or you can do 6 and then this x squared button right here, x squared equals. Or you can use your brain, because I think most of you know that 6 times 6 is 36. Similarly, for 5 cubed, you can either do 5 times 5 times 5, or, because there's not like a little button like the square one has, you can do 5 caret 3 to get 125. So that's how all these boxes up top go. At the bottom, you are to circle your perfect squares, draw an X over the perfect cubes, do nothing for numbers that aren't either of them. And then on your worksheet on the front of it, I do know that there are a couple that are going to have both perfect squares and perfect cubes. So I recommend that you go back to your notes. So here are your perfect squares, 1, 4, 9, 16. We're going to circle them. 1, 4, 9, 16, and then continue through the list. And then for perfect perfect cubes, 1, 8, 27, 64. No, 1, 8, 27, 64. So they're not all on there, right? Okay. And then I suggest that you continue through that whole list for this bottom section. All right, I hope that's helpful. If you have any lingering questions, I welcome you to email me at drones@d231.rochelle.net, and I'm happy to help. Thanks a bunch, and we'll see you in our next class. Bye.